All right, so I'm going to jump back into the fully lit version of my scene. And I'm going to move over here to where these candles are. As you can see, I have a little bit of a candle flame here. This is all just a particle system. As you can also see from here, this one I actually have a light on top of. I'm actually using a point light. This one I'm using a spotlight. And on this one, I don't have any light actor because the light itself is being emitted from the particle system. So I'm going to break down why I have 3 different versions of this candle in just a minute. But first I want to go in and show you how to set up a particle light. So I'm going to go into my particle system. So the particle system I have set up is this candle here. Same thing you just saw. And then the only thing different is that this one is actually using light in the emitter itself. So as you can see, this is my particle setup. It doesn't matter what your particle setup is. You can go in and add a light, and it'll actually emit from the particles that are emitted from your particle system. So in order to add a light, all you have to do is right-click, go down to Light, and then click on Light, and it'll add a light module. So once you have that light module added, you can choose whether or not to show it. So if I scroll down in here, go back into my scene, and then I uncheck this, you can see it's no longer emitting light. If I check it again, it is emitting light. And then under the light itself, you have all these different settings. A lot of these represent what you would get with a normal point light. And it is going to be rendered as a point light, so keep that in mind. It does become expensive, especially when you have a lot of particles going on. So if I go in here and I start tweaking some of the settings, you can see on this side exactly what they're doing. So this is the brightness, the overall brightness, right? So I set it to 0, 20, 40, 80, 500, right? Becomes more intense. Now you can see it is injecting into volumetric lighting. And that's also based on the volumetric scattering intensity that you have down here. So most of the settings that you have for a point light you have available in here. Now down here you also see that you have high quality lights and you have shadow casting lights. So in order for shadow casting lights to be enabled, you have to have high quality lights enabled. So if I check this and then check this, this will become a shadow casting high quality light. And you also have your overall light exponent and pretty much everything. For the most part, you have what you would see from the point light actor. You also have your radius scale, which is basically your attenuation radius. And then everything else is pretty much replication of what you get on the point light. Okay. So that is how you go and set up a particle light. Now the next light that I want to show you is going to be this point light. So what's special about this point light is that it's actually using a material function to slowly dim the light. So if you look down on the table here, you can see that the light is dimming in and out. If I go into detail lighting, you can see it a little bit better probably. So it's doing this because it has a light function attached to it. So if I go down into light function with this point light selected, and then I open up this light function instance, you can see the instance that I have set up is allowing me to control the overall opacity and minimum and maximum value. So it's going to be at its brightest, fully bright, and then at its dimmest, it's going to be 75% of that brightness, or 0.75. If I drop this down to 0.5, you can see it'll get much darker. Set it down to 0 to go fully dark, and it'll do it much faster. The scale is also controlling how this dims. It's basically a modifier of these two values. And then the speed is controlling how quickly it flickers. So I set this to 2, 5, 1, 0.5. So 0.5 is what I'm using for this currently. So in order to set up a light function, I'll go in and show you the master material for this. You have your root node here. What you do is you change your material domain to light function. And then that's it. And then everything that you plug into your emissive color value will control how the light is masked, right? So as you can see here, I've got a lerp that's linear interpolating between an opacity minimum and a maximum value. And then the alpha of that lerp is being controlled by this node tree here. So this is basically telling it to lerp between these two values based on this information. So what I have here is a multiply that's taking the sine wave and then multiplying it by a scale value. That's the scale that you saw in the instance. And then the end of the sine wave is going into a multiply that's multiplying the time by a speed value. So this is controlling how quickly it flickers. And this is the entire setup for this light. Now, if I wanted to go and do something like I showed you with the volumetric particle material, you could also apply that same technique here where you have like a panning material over it if you wanted to create some clouds or something like that, some shadows from clouds. And then you can have that pan over your light. And it'll basically just mask your light based on whatever information you give it. So if I wanted to, I can go in here and create a texture. Let's say I convert it to a parameter. Let's just give it a blank placeholder first. Convert it to a parameter. Call this one texture mask. Then throw it in a textures group. And then instead of plugging this directly into here, I could plug this into, let's say, the red channel of this mask, right? And if I apply these settings and go back into my instance, you'll see that I now have this texture mask as the only option. And I can just go in and grab any texture that I want to. Just filter textures for the entire project. And I can grab anything in here and use it as a mask. Let's say it's this. So now, as you can see, my light is actually masked by the texture I just threw into it. And let's throw in something else that's a little bit more easy to see. Let's try these flames, right? So as you can see, that becomes a mask for my light. And then once again, if I wanted to go in and do something like add a panner, and then, I don't know, just give it a speed. Let's say it's got a speed of 1. Plug the UVs into that. Once again, anything that you can set up in a material and use as a mask, you can use for a material function for the most part. See? And now I've got an animated mask for my light. So obviously you could use this for, as I mentioned before, water caustics, shadows from clouds, etc. So I'm going to set this all back to the defaults. And so now my light is just pulsing again. So the next one that I want to show you is going to be the spotlight, and this one is actually using an IES profile. So if I go and select the spotlight, and I collapse all of its options, and then I go down into light profiles, you can see that IES texture is now populated. And this one is called a bollard. And as you can see down here, I have a bunch of different IES profiles. So as I swap them out, you can see how it affects the shape of my light. Now, the reason you would want to use these over a light function, for example, these are not quite as dynamic as light functions. Obviously, you can't animate them or anything like that. But since they're only, they're basically just curve values, they don't require any textures or anything like that, they're a lot more memory efficient. So for cases like, if you want to create the shape of a flashlight glass, for example, or a specific type of a light or something like that, it would make more sense to actually use an IES profile rather than a light function, because it's going to be more efficient for memory, especially if you're running it in real time. So it doesn't have to load any textures or anything like that. And it's just masking it based on curve values, which you can see here. And if I check this little IES intensity box, it's actually going to use the intensity from the IES profile. This one seems to be pretty high, so I'm going to drop that back down. And then you have your overall intensity scale, which you can manipulate as well. All right, so the next thing that I want to jump into is going to be modulated lighting.